this is the first FRQ from the 2016 BC exam. So they give us a table for the amount of water that is coming out of a tank. It's being removed from the tank. That's the R. The water being pumped into the tank is W. And they do tell us that at T equals 0, there's 50,000 liters of water in the tank, so that's important. Okay, so part A says estimate R prime of 2. So R prime of 2 is going to be R of 3 minus R of 1 over 3 minus 1. We have liters per hour per hour. So there is the numbers kind of that we're going to use, and then our units. Since this is a calculator active question, I'm going to go ahead and use my calculator for all of this. So I've got 950 minus 1190. That's being divided by 2. So I've got negative 120 liters per hour squared. And it doesn't say that we have to have the context of the problem, but it did say units, so we've got our units. We're done with that one. Part B says use a left Riemann sum with 4 subintervals indicated by the table to find the total amount of water removed from the tank during the 8 hours, and then to determine if it's an overestimate or underestimate. So they kind of give you the clue with the Riemann sum, but we're going to have to use integrals for this. So from 0 to 8, R of t dt, and we're doing a left Riemann sum. So the first width is a width of 1, and then height from the left, and then width of 2, height from the left, width of 3, height from the left, width of 2, height from the left. Okay, and then if you type that all into your calculator, you get 8,050. If we were to graph this, we would see that, I'm not going to draw like an accurate graph, but the numbers are going down, right? So if you were to do left hand Riemann sum, which is what we did, then you can see that all of those are going to be overestimates. So we're going to say R of t is a decreasing function. So left Riemann sums give an overestimate. All right. Part C says use our answer from B to find an estimate of the total amount of water in the tank to the nearest liter at the end of 8 hours. So we're going to say at 0 you start with 50,000. You add the water that's being pumped in. You subtract the water that's being removed. So we're going to say 50,000 plus, from 0 to 8, W of t dt, the integral, minus 8,050 equals. Okay, so I'm going to go ahead and very carefully plug in W of t just in here. This is a habit that I've gotten into because it saves me from having to type this in multiple times, so I'm not risking typos. So 2,000 e to the negative x squared over 20 looks good. Okay, so 50 minus that was plus. That was water coming in. There's the water coming in minus the water going out. So we have 49,786.195 liters, and then they want you to round to the nearest liter. So I'm going to say 786.195 if I round to the nearest liter. All right, so for the interval from 0 to 8, is there a time when the rate at which the water being pumped into the tank is the same as the rate at which the water is being removed? So they're saying, like, is there a time when they're, like, neutralizing each other, right? So for part D, you can say, okay, so we're looking to see if W of t can equal R of t, which means that we want the water going in and the water going out to zero out. So that's basically what we're looking for, is we're looking for like the intermediate value theorem. We're just combining two functions to do it. So if you can imagine, you could say, you could like call this another function. You could say, like, I don't know, I'm going to do k because my name starts with a k. We could say k of t is defined as like how much water you end up getting, and then this is what it's in terms of, or something like that. And so this is kind of like what we're trying to find the intermediate value of. So we're looking at plugging in 0. We're looking at plugging in 8. So if I do W of 0 minus R of 0, I've got W of 0 minus, and then R of 0 is 1340. So that's 660. Okay, so that equals 660, which is greater than 0. And then we're going to do W of 8 minus R of 8 and see what we get. So W of 8 minus R of 8 is 700. That's a negative value. Negative 618, which is less than 0. So since on one end of the interval you have something greater than 0, on the other end of the interval you have something less than 0, then somewhere between those you're going to hit 0 exactly, which means that the two rates are going to be equal to each other. So I'm going to say that this right here is continuous on 0, 8. And you know that because it says that R of t is differentiable. And then I guess you could kind of say that you know that this is differentiable because we did differentiate it. Either way, I would definitely say it's continuous, even if you can't say why it's continuous. Just throw that out there when they're clearly going for that, because that's one of the parts we have to say for mean value theorem or intermediate value theorem, which is what we're doing right now. So I just went ahead and threw out there that it's continuous on that interval, and then I'm going to say by the intermediate value theorem, there is some value C on 0, 8 such that W of C minus R of C equals 0. And so, you know, yes, there's a point where those two values are going to be the same. You could say, or W of C equals R of C.